Okay, section 6.7 is all about solutions, and this is the last section in your chapter. So a solution, as a reminder, is a homogeneous, or you can say homogeneous, mixture of two or more substances, and that means that it's stable throughout. It should look the same. If it's some kind of food, it should taste the same. The texture should be the same. It should be thorough throughout. And a homogeneous mixture, or any sort of mixture for that matter, is always dealing with a physical change, not a chemical change. So again, it's dealing with a physical change. So you're going to get this mixture from shaking or stirring, or maybe it's melting. Two components of a solution are a solute and a solvent. So a solute is the substance that is dissolved, and the solvent is the substance doing the dissolving. So for example, if we have sugar water, we have sugar and water, two substances, and they get mixed by stirring. So there's your physical change. And the solute would be the sugar because it gets dissolved, and the solvent is the water because it is doing the dissolving. If you ever see the term aqueous, aqueous always means water. And in reactions, if you have an aqueous solution, you'll see an AQ behind the substance. So for example, if we have sugar water, that would be C12H22O11. And to show that it's dissolved in water, we would put that AQ behind it. Okay, with solutions, let's talk about what's diluted versus what's concentrated. So for example, let's say that you're making Kool-Aid and you want your Kool-Aid to be more dilute. What would you do? You would add more water, or you would add less of your powder, of your Kool-Aid powder and your sugar. Let's say you wanted to make your Kool-Aid more concentrated. You would either decrease the amount of water needed, or you could increase the amount of Kool-Aid powder, flavoring, whatever you call it, and the sugar. So dilute means that you have usually a lower amount of solute and a higher amount of solvent. Concentrated, your solute's higher and your solvent is usually lower. Okay, there is some math in this section. And the first thing we're going to talk about is molarity. So molarity is the most common concentration unit. So when we say concentration in chemistry, we are talking about whether it's dilute or concentrated. We're just talking about the solute versus the solvent and what's happening between the two. So here is the equation for molarity. Molarity is big M, that's how it's notated, and it means moles of solute over liters of solution. You'll be given this on the test, so you don't need to memorize it. And you can solve for either moles or you can solve for liters. So if we solve for moles, the equation is molarity times liters. If we solve for liters, it's going to be moles divided by molarity. This is just a 3-variable equation. You don't have to memorize any of this. You can just plug things in, or you can rearrange the equation. One thing that I like to show is I call this the triangle of molarity down here. And I'm going to do a multiplication and a division sign. So for example, if you were trying to find moles, you could cover this up and you would know that moles would be molarity times liters. Or if you were going to try to solve for liters, you would cover up the liters and you would see that it would be moles divided by molarity. This is just kind of a fun way to remember if you don't enjoy the math aspect. So let's do a couple problems. The first example, I'm going to go ahead and underline things as I read this out loud. It says, calculate the molarity of a solution made by dissolving 0.65 moles HCl in enough water to produce 795 milliliters of solution. So first off, let's look at what we have. We've got molarity, that's our unknown. So big M. We have moles and we have a volume. And we only have 3 variables, so this has to be a molarity equation. So molarity is moles over liters. And when we're doing molarity, you have to have these units. You have to have molarity, and you have to have moles, and you have to have liters. At least 2 out of the 3 that you're solving for. You have to have these units. So we already have moles, which is 0.65, but notice our volume is in milliliters, so you need to convert. So a common conversion you're going to use with molarity is going to be milliliters to liters. So that's 1,000 milliliters is equal to 1 liter. So we're going to go ahead and divide 795 milliliters by 1,000 to get it into liters. That's going to equal 0.795 liters. So now we have the correct units. Now all we have to do is just plug it in. So we're going to get 0.65 moles divided by our 0.795 liters. And that will give us a concentration, also known as a molarity, of 0.82 molarity. So when we see this, what this means is that we have 0.82 moles of solute, if I can spell that right, solute, wow, that's pretty terrible, moles of solute in 1 liter of solution. So if you think about 0.82 moles and you would convert that to grams, that's not a very large amount. So whenever you have molarity, the smaller the number, the more dilute the solution is because it doesn't have as much solute in it. The higher the number, the more concentrated the solution is. So for example, if you have an 18 molar solution, what this means is that you have 18 moles of solute. Let's say it's sugar water. You'd have 18 moles of sugar, which you can convert into a mass to figure out how much you would need. And you've got it, 1 liter of total solution. So the total solution with the solute is only 1 liter. So this would be a very concentrated solution. So again, the higher that number with molarity, the more concentrated. The lower the number, the less concentrated. Just so that makes a little bit of sense. If you think back to doing things in the lab, sometimes we had solutions we used and it would be like a 1 molar or a 0.1 molar. So that's what this is dealing with, is the concentration of those solutions. Okay, let's do another example. What volume of a 3 molar, so instead of saying molarity, a lot of times I'll say molar, 3 molar NaCl is needed for a reaction that requires 146 grams of NaCl. Oh, and I forgot my volume. So question mark equals volume. And we know that this is dealing with molarity because this is the only equation that we have in this chapter that has a capital M for molarity. So we know that this is going to be liters unless the question asks us to solve for a different unit of volume. Okay, so we've got liters. We know that we need liters. We have molarity, and then we have 146.3 grams of NaCl. Well, our equation tells us that we have to have moles over liters, so we have got to convert this 146.3 grams of salt into moles. So this is just our molar mass equation. The mass of sodium is 22.99. The mass of chlorine is 35.45, which equals 58.44 grams. That goes on the bottom to cancel out the grams over there. The top left. That all equals 1 mole of NaCl. So the grams of NaCl cancel. We divide that and we're going to get 2.5 moles of NaCl. Okay, so from here, now that we have the correct units, all we have to do is just plug in our information. So you can do this however you want to. Let's say that we're just going to manipulate our equation. So let's use this up here. So whenever we have an unknown as our denominator, you got to get it out of there. So the first thing we're going to do is multiply liters by both sides. That's going to cancel out our liters. So now we have liters times molarity equals moles. And now we need to get rid of the molarity. So liters is by itself. So we're going to divide by molarity. So now we have liters equals moles over molarity. Or you can go look at the triangle. The triangle is going to show you the same thing if you cover up liters. So let's plug in. So 2.5 moles of NaCl, I'm just going to use this, divided by molarity, which is the 3 molarity. That is going to give us 0.83 liters. And that would be our answer. So just a couple of things here. Again, when we have equations, you can plug things back in, but it has to be in the correct units, and you can solve for something else. So if we wanted to know if the liters was accurate, we could pretend we're solving for molarity and do the 2.5 moles over 0.83 liters, and it should equal 3 or very, very close to 3, dealing with because of rounding. Another thing I like to do is I like to see my units. So instead of writing molarity, sometimes what I'll do is I'll do moles over liters. And whenever we're dividing by something that has a derived unit, remember what happens here is that this will flip. So we get moles, and then we get moles divided by liters. This whole thing will flip. So up here what we get is liters over moles. And then if you notice, the moles cancel and we're left with liters, which is why we get that unit. You can also solve for moles in the molarity questions, and sometimes the molarity questions will ask for a mass, which means if it's asking for a mass, you're going to have to solve for moles, and then you're going to have to do a molar mass like we did here to figure out the amount of grams. Okay, let me know if you have any questions. My family just got home, so things are going to get loud, so I'm going to sign off. Sayonara.